Welcome to Let's Talk Micro. Hello, my dear audience. Welcome to another episode of Let's Talk Micro. As always, I hope you had a great week. And you can always find Let's Talk Micro on Apple Podcasts, Spotify, Amazon Music, GoodPods, wherever you listen to podcasts, you can find Let's Talk Micro. As far as social media, I am on Instagram, TikTok, and YouTube as Let's Talk Micro, on X as Let's Talk Micro 1, on LinkedIn as Luis Plaza, and I have an email address which is letstalkmicro@outlook.com. So either via social media or via email, you can reach out with any suggestions, any feedback. Those are always welcome and appreciated. So please go ahead and subscribe to the podcast, download episodes, and if the app allows you to do so, please go ahead and leave a review. Thank you so much for the support. I am always so grateful with all the wonderful reception that Let's Talk Micro is having. And if you are looking to learn more about antibiotics, please check out www.learnantibiotics.com and the Learn Antibiotics book available on Amazon. These resources include cheat sheets, practice tests, games, and more, and they are being used by thousands of people worldwide and may be helpful for you or your colleagues. And those, of course, are some wonderful resources from Dr. Timothy Gauthier, who's a very passionate pharmacist, and he was a guest of the podcast where he came in and he talked about antimicrobial stewardship, antibiograms, and more. Great episode. If you haven't checked it out, please go ahead and do so. And as you know, Let's Talk Micro does not have any sponsors. So one of the goals of bringing more content, is to attend different conferences and going and, meet people and bring potential guests. So if you want to support the podcast in any way, you can do so by a Venmo link, which is in the show notes, and also by buying a coffee, KO-FI, which is in the show notes as well. Well, anyway, thank you for the support if you end up, supporting the podcast in any form. Thank you. And if you haven't checked out the previous episode, please go ahead and do so. I continued the journey through gram-positive rods, and this time it was Corynebacterium's turn. I give an overview of the species, and Corynebacterium, they're catalase positive, gram-positive rods. They are non-spore forming, and they are aerobic and facultative anaerobic. And for the students out there, I just want to say that, keep that in mind, as, I talked about that in the previous episode, but that's the difference between Corynebacterium and Bacillus. So with Bacillus, you see spores. With Corynebacterium, you don't. And this is something that is used, when you are doing gram stains for gram-positive rods, and you kind of classify them, you group them into different morphologies. And you use terms, like for Bacillus, you use terms like, like boxy, large gram-positive rods. For Lactobacillus, long and thin. And for Corynebacterium, coroniform, palisades, V-shape, Chinese letters. Those are things that you hear when it comes to Corynebacterium. But when it comes to gram-positive rods as a whole, this is something that you use when you are identifying them. And the genus of Corynebacterium, along with other genera, are considered coroniform bacteria. So they are short or slightly curved rods which are arranged in palisades. They are club-shaped, which actually, Coryne means club in ancient Greek. And I mentioned examples of other genera. I also talked about the term diphtheroids that we hear in the lab, and these are species recovered from clinical specimens but deemed non-pathogenic. And this is something that those of you that work in the lab as medical laboratory scientists, when you are working cultures and you see these colonies, they can be white, large, small, and you do your gram stain and you see the coroniform bacteria, you typically make a note saying, these are diphtheroids and you call it normal skin flora. There are some situations that I talked about in the episode when you can start thinking of them as pathogens. And this is basically when it's the only thing growing or in large amounts, like large colony counts. In the episode, I also talked about the fact that, that it can be difficult to establish pathogenicity because many of the species are recovered from the environment and some are part of the normal flora. I also went over media and biochemicals, and I pretty much ended the episode talking about Corynebacterium diphtheriae. In rare cases, it is isolated from humans. It is primarily transmitted through respiratory secretions or skin lesions, and the disease caused by this organism is diphtheria, but it is only caused by strains that produce the diphtheria toxin. And the toxin kills healthy cells, and the dead tissue forms a membrane called a pseudomembrane that causes the patient to have a hard time breathing or swallowing. So definitely a great episode with great information. So if you haven't checked it out, please go ahead and do so, and definitely go ahead and check out the series about bacillus as well. Especially if you're a student, so you can just start, building your notes and putting everything together in preparation for your exam. And I pretty much ended the episode talking about different media. Well, I mentioned the names, but I didn't go over it. Media that is used to isolate Corynebacterium diphtheriae. And that's what I'm going to be talking about in this episode, on today's episode, with some other things. So, I mentioned cystine, tellurite agar, modified Tinsdale agar, and Loeffler medium. So let's go ahead and talk about this. The first one is cystine, tellurite agar. And I'm going ahead and talk about them individually, but both cystine tellurite and Tinsdale agar have a high concentration of potassium tellurite. And that, of course, brings the question, what does this do? Well, it inhibits normal flora. And then you might ask, what does cystine do? Well, it enhances the growth of fastidious organisms, including Corynebacterium diphtheria. And I want to go over some things before I actually go over the agar. When it comes to Corynebacterium diphtheria, the isolates are divided into 4 biotypes. And the biotypes, they're classified based on the morphology and biochemicals. And they are gravis, mitis, belfanti, and intermedius. And I hope I'm pronouncing them right. I'm reading for a textbook. I haven't had much interaction with Corynebacterium diphtheriae, so forgive me if I am, mispronouncing them. As mentioned in the previous episode, species of Corynebacterium, they grow on blood agar, and the morphology, it can vary depending on the organism, on the species. So when it comes to diphtheria, Corynebacterium diphtheriae, the morphology of the colonies on blood agar, it varies with the biotype. For example, with biotype intermedius, the colonies are small, gray, and translucent. When it comes to biotypes mitis, belfanti, and gravis, they can be medium, white, and opaque. And I talked about Corynebacterium ulcerans and pseudotuberculosis, that they can actually carry the gene for the toxin as well. So those, they resemble C. diphtheriae on the agar. But definitely, for the medical laboratory scientists and the students, remember that a lot of, typical Corynebacterium colonies, they can be anywhere from white, you can have large colonies, you can have like pinpoint, irregular morphologies. So this is something very important to remember, that when you see white colonies, don't assume it is cocci. And I talked about that, and it's something that I talk about a lot, that the gram stain is something that's very important. So don't assume. With white colonies, you can have yeast, you can have GPR, you can have GPC. So take the time to use that wonderful tool, and it can help you from making a mistake, which at the end affects your patient. And in this episode, I'm going to be talking about those 3 mediums, and they are from, the ones that I'm talking about, they are from Fisher Scientific. No sponsorship, just so you know. So this is not a sponsorship, this is not a plug or anything, but it's just, some information that I found, and I'm going to be sharing it with you. So let's go ahead and talk about cystine tellurite blood agar from Fisher. So it is used for the isolation of Corynebacterium diphtheriae. It has peptones, which provides nitrogen and carbon compounds. It has sodium chloride, which supplies electrolytes and maintains osmotic balance. The medium is differential, and the differential portion is provided by potassium tellurite, which is reduced by Corynebacterium. And as I mentioned before, it inhibits gram-positive and gram-negative bacteria, allowing Corynebacterium to grow. It is recommended that both the throat and nasopharynx are cultured in order to maximize the recovery of Corynebacterium diphtheriae. So you will go ahead and you plate the sample as you normally would on the media, and then you go ahead and incubate it aerobically at 33 to 37 degrees for 24 to 48 hours. And then after that, you examine. So your colonies are, the colonies of Corynebacterium diphtheriae, They are black or gray, and they can have a halo, which is due to the breakdown of cystine. One limitation of the agar is that colonies of staph or strep can be black due to the reduction of tellurite, but of course this issue can be resolved by a gram stain. So there you go again, a wonderful tool, something to keep in mind. And this is, typically with other medium, when you get like, chromogenic agar or media that's designed to isolate a particular organism, if you're unsure, you can go ahead and do a gram stain. So that's simple enough, and you check. For example, like chromogenic agar for MRSA, and like if there's one where the MRSA colonies are green, but sometimes you can get other things growing and they can produce green colonies. So when unsure, you can go ahead and do a gram stain. In the case of MRSA, you see gram-positive cocci, of course, and in the case of Corynebacterium, you do a gram stain and you see gram-positive rods, coroniform shape. And another thing is that it is recommended that you keep the plate for 48 hours before you report it as negative. So that's why, incubate from 24 to 48 hours. Now let's go ahead and talk about Tinsdale agar. So this agar was developed to isolate and differentiate C. diphtheriae. In this medium, Corynebacterium diphtheriae colonies, they are black with a brown-black halo after 48 hours of incubation. Colonies of Corynebacterium ulcerans also produce this halo. Diphtheroids and other organisms do not produce this type of colonies. As mentioned, the medium has tellurite, which is reduced to tellurium, producing the gray to black colonies. And the halo is because hydrogen sulfide is produced from cystine. And once it is produced, it interacts with the tellurite, producing the halos. Besides potassium tellurite and cystine, the medium also has peptones and sodium chloride. So sodium chloride for your electrolytes, osmotic balance, peptones for, carbon source. So you go ahead and plate your sample as you normally would, and you incubate the agar at 35 to 37 degrees in aerobic conditions for 24 to 48 hours. Then after that, examine for those distinctive colonies. As far as limitations, if the medium is incubated in a CO2 environment, carbon dioxide, this can delay the formation of the halos. Also, some colonies of staph and strep might produce those colonies with halos. And then there is Loeffler medium. So older cultures of Corynebacterium diphtheriae, they have metachromatic granules. And these are used for storing organic polyphosphate. Loeffler's medium is used to stimulate the growth of C. diff, Corynebacterium diphtheriae, and the production of these granules. And I am going to talk about this medium, and however, it is no longer recommended to be used as a primary medium for throat swabs because of overgrowth of normal flora. So the medium was initially developed for the cultivation of Corynebacterium. It has horse serum, beef heart infusion, and dextrose. And this media enhances microscopic and colonial morphology, virulence, and chromogenesis. And it can even bring some of those properties back, and that's what the package insert says from Thermo Fisher. Well, dextrose is used as a carbon source. The horse serum is a protein source. And you go ahead and plate your sample. And for potentially contaminated samples, it is recommended to plate it first in a medium such as Tinsdale or cystine tellurite. Once your sample is plated, you can incubate it at 33 to 37 degrees aerobically for up to 4 days. Corynebacterium diphtheria colonies are cream color with slightly raised centers. From this, you can go ahead and prepare smears and stain them with Loeffler's methylene blue stain. Then you can go ahead and examine those for the dark blue metachromatic granules. Then it is recommended to subculture the colonies to blood agar for additional testing, like biochemicals. As far as limitations go, so the strain needs to be toxigenic to be diagnostic of diphtheria. And I mentioned this in the previous episode, but it is just good to keep it in mind that not all strains of Corynebacterium diphtheriae carry the toxin, So this is something that you have to keep in mind. Just because the organism is growing does not mean that it causes diphtheria. And this, Corynebacterium, diphtheriae, pseudotuberculosis, and ulcerans, they can carry the gene, which is actually transmitted by bacteriophages. So this is something to keep in mind. And in all honesty, in the lab, you might never see it, or maybe if you see it, might be infrequent. This is not an organism that you isolate frequently. I mean, I think at one point in time, I maybe seen it once in the lab, and I'm not sure if it was producing the toxin or not. I mean, I remember that it was identified by Malitov, and I'll talk more about this, about identifying Corynebacterium, but definitely it is not a common organism. So this is something that you might not see a lot, and especially, I speak a lot more on from the United States side, and with vaccination and things like that. And I know like this is a hot topic and a very polarizing topic, but I'm not gonna expand on it. But a lot of people they're vaccinated. They get the diphtheria vaccine. So it is an organism that you might not see, and then even if you see it, it might not be carrying the toxin. So it's something that maybe if the physician is suspecting it, if the information leads to that, then definitely let the lab know. So we can kind of keep an eye and start. Maybe if we have this media, and maybe we can use that and think about that. But normally, it's not the first one that comes in mind when it comes to respiratory pathogens. And I just want to circle back real quick to the Loeffler's medium. So non-toxigenic strains will grow on the agar as well. So that's why I said that, in order to be diagnostic of diphtheria, it needs to be producing the toxin. So you can get just regular strains growing on it. So if you have isolated this organism in the lab and this is, diphtheria is being suspected, then if you're going to test for the toxin, there are two methods that are commonly used. And those are nucleic acid amplification testing, NAT, and ELIC. So I am just briefly going to touch on ELIC testing. This is an immunoprecipitation test. And what you do is there is a disc that has the toxin, and you place that on an ELIC plate that is inoculated with the test strain and the control. Then the toxin diffuses through the agar and produces a precipitin line with toxin producing isolates. And in the literature, there's also a modified version of it. So if you want to learn more about it, I definitely invite you to, do using a search engine, search for the ELIC test and do more research on it. But definitely, the ASM, American Society for Microbiology, it has some publications on it. So if you want to find out more, please go ahead and do so. So we have this media that helps us, isolate Corynebacterium diphtheriae. And of course, when it comes to identifying in the lab, there are many methods that can be used. But definitely the popular ones, like Molotov, you can identify it. You can also identify it via the API Corynea system. And maybe those of you that are younger techs, or maybe you're working in a facility that has like Molotov and things like Vitek, you might not be familiar with the API system, but it is still used. It's definitely very popular. It is used in many labs, and of course, maybe the use might be reduced depending on the instrumentation that you have and things like like gene sequencing and molecular tests that make advances. And I will talk more about the API systems at some point in the podcast. Definitely, I work with API and I use it for enterobacteriales and non-enterobacteriales. So I have mixed opinions with it. But definitely in laboratories where they don't have instruments like Molotov and other systems, this is one of the primary methods used for testing. So I'll talk more about that at some other time. But when it comes to Corynebacterium as a whole, definitely Molotov is a big one to identify them. And then of course, Vitek has a card called the ANC, which identifies different species of Corynebacterium. And that will be a separate episode talking about the Vitek. And there is also the rapid CB test, which I always have some mixed opinions about it. And this type of test, it typically involves your result produces a number, which it's a code, a combination of numbers, and then you put it in a database, and an ID is produced. And sometimes, people might tinker a little bit with the numbers, positive, negative, to get a result. So that's maybe one I am not such a fan of it. But it's a system that is out there, and it's in smaller labs where maybe you don't get that much testing. It's something that is probably used. Okay, so let's go ahead and recap. So today we talked about Corynebacterium diphtheriae, and there are 4 biotypes, which are classified based on the morphology and biochemicals, and I mentioned the names, and I talked about the morphology on blood agar, and then there is media that is used to isolate Corynebacterium diphtheriae, which helps differential media, and these are cystine, tellurite agar, and modified Tinsdale agar. And at the end, it has potassium tellurite, which is reduced, and that causes a color change. The colonies are black to gray. And then there's a halo produced, which is due to the fact that, the hydrogen sulfide is produced from cystine, and this interacts with the tellurite, then thus the halo is produced. And then there is Loeffler's medium, which stimulates the metachromatic granules, which can be seen by performing a Loeffler's methylene blue stain. And as always, remember that if you get questionable colonies and maybe you're not sure if that's what it is, always do a gram stain. Because as mentioned, sometimes, species of staph and strep, they might produce black colonies, they might grow on the medium. So when in doubt, go back to the basics and look at the gram stain. It's definitely such a helpful tool, and I cannot emphasize this enough to the techs. In a world of gene sequencing, of Molotov, of molecular testing, please don't stop doing gram stains. I beg you. It is still such an important tool, and it helps you with your job. So please continue them. Remember that a human being is at the other side of those tests. So keep that in mind when you are doing your testing, and use all the tools that you have at your disposal to maximize, to produce the best outcome for your patient. And that, my dear audience, is the end of this episode. I hope you enjoy learning about different media used for the isolation of Corynebacterium diphtheriae. As always, I enjoy sharing this information with you. As you are listening to this, we are celebrating Lab Week, Laboratory Professionals Week in the United States. So thank you so much. Happy Lab Week. Thank you for everything you do. And not only those laboratory professionals in the United States, but from all over the world. We all have different terms, right, for our names, like medical lab scientists, biomedical scientists, so many different designations. But thank you for everything you do. Your work is so important. A lot of times it feels that we only hear from other people when we're doing something wrong. But, we face so many challenges. We're short-staffed. COVID was a big challenge for us. We navigated past that. So thank you. And so take the time to say hello and thank you to a fellow professional. If you stop by the lab, let them know, hey, you're appreciated. It's always great to hear that. And definitely shout out to the ASCLS Florida for inviting me to speak last week. Thank you so much. So thank you to Dr. Maridalis Rodriguez and Emilia Marrero. Shout out to you. Thank you again. As always, thank you for the support, for downloading episodes. Great things coming your way. And please continue bringing that passion to what you do. It's so important. You do such great work. So, as always, stay motivated, stay safe, and of course, continue talking micro. Until the next time. Bye.